Welcome to NumPy indexing for absolute beginners. NumPy lets us work with large sets of numbers quickly and easily. Today you will learn how to select, change, and use data in NumPy arrays. You do not need to have used NumPy before. Get ready to build the skills you need for science, data, and more. Running the cell now. Try to follow along and pause if you need to practice. If you enjoy this video, remember to like and subscribe for more tutorials. Step 1. Importing NumPy. Before we can use NumPy, we need to import it into our code. It is common to use the nickname NP, so we type less. Running the cell now. Let us get started. First, we bring NumPy into the notebook using the import command. Now we can use the letters NP anytime we want to use a NumPy feature. Running the cell now. Let us create our first NumPy array with some numbers. Printing the array shows all the values at once. This list of numbers is now inside a special NumPy array. Running the cell now. Try to change these numbers and run again for practice. Step 2. What is indexing? Indexing means picking out values from an array by telling Python which spot we want. In NumPy, indexing is super fast. We start counting from 0. Running the cell now. Here we grab the first value using the number 0. Printing shows that 0 means the very first spot. Running the cell now. Change the 0 to another number and see what happens. We can get the third value by using a 2. Printing shows which number is in the third spot. Start counting with 0 for the first value. Running the cell now. Negative numbers start counting from the end. This lets us get the very last value in the array. -1 means the last spot. Running the cell now. Try other negative numbers and see what values you get. We can ask for part of the array using a colon. This gets spots 1, 2, and 3 but not 4. Running the cell now. Slicing helps you get chunks of data at once. Let us try grabbing every second value using double colons. Printing shows the values it picked. The double colon controls the step or skip amount. Running the cell now. Change the number after the colon to skip by 3s or 4s. Step 3. Indexing with 2D arrays. NumPy can make arrays with more than one row. Indexing works a little differently. We pick row and column. Running the cell now. Let us see how to work with two-dimensional data. Here is how to build a grid or a matrix using lists inside lists. Each inner list is a row. Now we have 3 rows and 3 columns. Printing shows the grid all at once. This type of array is called two-dimensional or 2D. Running the cell now. Try adding a 4th row and see what happens. We can pick one value by giving 2 numbers, row first, then column. This command gives us the value at row 1, column 2. Running the cell now. Try changing the numbers to get different spots in the grid. Using a colon grabs all rows at once. This pulls out every value in the first column. Running the cell now. This is powerful for working with real-world tables of data. NumPy lets us update any value by using indexing. Let us change the value in the first row, second column to 42. Printing shows the new version of our grid. Updates like this are very common in data science. Running the cell now. Now, see if you can update something else in the grid on your own. Now you pick which value you want to see using input. We ask the user for a row and column. They choose using numbers starting at 0. The computer then shows which value is at that spot. Running the cell now. Practice changing inputs to explore your array. Step 4. Boolean indexing. We can use true and false to select values based on condition. This is called Boolean indexing. Running the cell now. We can make a list of just the numbers greater than 25. Printing shows only numbers that match the rule. In NumPy, we can filter arrays with conditions like this. Running the cell now. Try other conditions, like less than or not equal to a number. Here we look for spots in the grid where the value is even. The percent sign gets the remainder. Two equal signs mean equals exactly. Running the cell now. What happens if you try grid %2 equals 1? Step 5. Fancy indexing. Fancy indexing means using a list of numbers to pick out any positions you want. This is very fast and makes NumPy powerful. Running the cell now. You can use square brackets with a list to grab many spots at once. This picks out the second, fourth, and fifth values in the array. This is called fancy or advanced indexing. Running the cell now. Try picking different positions in any order you wish. Fancy indexing works with two-dimensional arrays too. Here we get only the first and last rows out of the grid. This is useful for selecting specific data. Running the cell now. Now, see if you can use fancy indexing with columns as well. NumPy has a function to sort arrays for us. Let us try sorting a new set of numbers. The result is a brand new, ordered copy. Printing shows the sorted values. Sorting is helpful when you need to see data in order. Running the cell now. Test trying np.sort on a different array. With Boolean indexing, we can filter two-dimensional arrays too. Here are the grid values that are bigger than 3. Filtering large data sets is easy this way. Running the cell now. Try filtering for values less than or equal to 8. If you have two arrays, you can combine them into one. Let us stack numbers and extra together in one call. The result is a bigger array containing all the items. This can help you organize data from multiple sources. Running the cell now. Combine arrays of different shapes and see what errors come up. Step 6. Mini project, student test scores. Let us use our new skills in a short project. Imagine we have test scores from 3 students on 4 tests. Running the cell now. Stay tuned for the second part coming up. If you learned something new, be sure to like, comment, and share this video with your friends. We create an array where rows are students and columns are test results. Printing shows us the student data. Now we have all scores visible for analysis. You can imagine this as a real-world classroom. Running the cell now. Try putting your own scores in this table. NumPy makes it simple to find the highest result in each row. We use axis equals 1 to look across each student. The output shows the top score for each student. Running the cell now. For practice, try finding the lowest score for each test column. Using Boolean indexing, let us find every score greater than 90. This is helpful for spotting top results quickly. The print statement shows all matching scores. Running the cell now. See what happens if you change the number from 90 to 85. It is easy to make a typo with indexes. Here we try to access a spot that does not exist. Python will raise an index error, but we can catch it. The program prints a helpful message instead of crashing. This is a good habit when working with new data. Running the cell now. Practice causing an index error and fixing it. Step 7. Final tips. Indexing is key to almost everything in NumPy. Practice with your own arrays and slices. If you get errors, check your index numbers. For more, try searching for NumPy array indexing online. Congratulations! You have built a strong foundation. Running the cell now. Try making a new array and practice indexing in as many ways as you can. Thanks for learning. If you liked this video, please hit like, leave a comment about what you learned, and subscribe for more lessons. Share this video with a friend who wants to learn programming. Happy coding with NumPy. Running the cell now. See you in the next tutorial.